Hello again. Welcome to the Unisky training platform. Remember to subscribe to our YouTube channel for more videos. Now, in this particular video, we are going to learn how to create simple topologies. For example, we are going to create a simple network topology for an institution with about 3 different branches where they are all connected via switches and then are all controlled from one router from a central point. So given the canvas, we would just put a logical presentation of how controls or objects can be used in the canvas to draw a topology or to come out with a typical or a logical framework of our view. So we start by adding our router, because we would need a router to control the whole topology. So we pick our router, then we bring a switch. So we can use the default switch there, and then we would need, for example, client PCs around. So you just drag and drop your client PCs. So we drag and drop about 3 different client PCs. Then now we establish a connection between these devices. So as usual, we pick our copper Ethernet port 1 to port 1 here, and then from our PC we are connected to this, then from port 3 to this PC, and then from this particular port 4 to this PC. So we can actually do this for all devices, irrespective of the number of devices we have on our network. In this particular video, we would look at assigning static IP addresses to the PCs. Then in another video with the same topology, we would look at assigning dynamic, setting up a DHCP server, a dynamic host configuration protocol service on the router, where it would assign dynamic IP addresses to the underlisted computers below. But for now, we are just going to assign simple static IP addresses to these particular PCs on this particular switch, and then we'll add another switch and see if we can be able to place an ICMP from maybe PC1 on switch 1 to maybe PC7 on, say, switch 2. So we can add another switch here, and then we establish a connection from this particular port to this one, right? Then we can have our PCs. Okay, so we connect PC4, PC5, and then PC6 to this particular network. So we establish the connection from this PC to that, then from here to here, and then from here to here, right? So now to assign an IP address to a PC, we simply double click on the PC, and then maybe we can name the PC. So in this case, we want to name this, say, host A. Then the IP address for host A, we probably want to give it 10.0.13.1, and then a subnet mask of 255.255.255. We apply, and then we close this. Then for PC2, so that is host B, we assign 10.0.13.2, and then a subnet mask of 255.0 plus B. Then we go to the third PC here, that is our host C, and then we assign 10.0.13.3, then 255.255.255.0. It must be a valid subnet mask, right? Let's remember to turn on these devices too eventually. Now on our router, we want to enter the system view. So we say system-view. Then we want to change our router name. We use the sysname, so which is what, RT1. That is the name we intend giving our router. So our router is now RT1, and then we assign an IP address to the port 0. So if we display, we currently have no IP address there, IP interface brief. So you would realize that there is no IP address assigned to any of these interfaces. So now we are going to assign an IP address to the gigabit Ethernet port 0/0/0, right? So we navigate to it. So we say interface giga 0/0/0, and then we assign the IP address by saying IP address. Then we specify the IP address we want to assign to it with 10.0.13.254. That is going to be our IP address for the router, and then we assign a subnet mask of 24 bits to it. So once our command succeeds, it means we have successfully added an IP address to the router. So let us try and see if our router can communicate to PC1 via maybe the switch, through the switch. So we start to capture our data and see. It's taking some time for me to start my packet, my Wireshark. It will start very soon. Just bear with me a bit and let's start it. So once the Wireshark is started, we realize that at the moment it is not capturing any data. So at the moment our Wireshark is not capturing any data. There is no record being captured at the moment. So we set a ping request from PC1 to the router. So from PC1 we come to the command and then we ping 10.0.13.254, and then let's observe what happens. Our Wireshark has started capturing an ARP, and like an internet control message protocol is sent. It's typically in the ping request. So we realize that there is a request made and then a reply is given. So we realize that we have a reply from our destination. So that means there is a communication between router 1 and router 2. Now, if I turn this particular device on and turn this on, so let's turn these devices on for now. I need to get my switch is still starting, but I think the PC is on. So let's assume I give this particular computer 10.11.0.1. Now this particular IP address is different from the IP address I assigned here. Right, it is different from the IP address I assigned here. So we are going to ping this particular computer. So we are going to make a ping request from PC1 to PC6. Now PC1 is configured to respond to notepad. So PC1 is configured with 10.11.0.1. PC6 is configured with this, and then PC2 is configured with 10.0.13.1. So we have this particular PC here. PC1 is configured with this particular IP address, and then PC2 here is configured with this particular IP address. So let's see if we can be able to configure PC2. In our case is PC6 on the screen. So we ping from here. So ping 10.11 10.0.13.1. What happens? We don't get a reply. We get a request timeout because this particular network and this network are different because the IP address we have set splits the network. We realize that this one is one on a class C IP address. It is with a subnet max 255.255.255, and the IP address itself is entirely different from the IP address of this particular computer. That splits the networks. But if we have this particular computer, say 10.11.0.2, and a subnet mask of 255.0.0.0, we expect it to be able to communicate with PC6. So when we make a ping request to PC5 from PC6, which is ping 10.11.0.2, we expect to get a reply. So we have a simple topology out here. So we can have this set of computers in one department, and then we can have this set of computers in another department, of which we can split VLANs, and then we can have different configurations passing through these switches. Of course, they should be either layer 2 or layer 3 switches so that it will allow for the service we want it to carry. So this is a simple topology of maybe an institution with more than one department, and then maybe we are connecting them via 2 or more switches. Thank you for watching, and then remember to subscribe to our YouTube video for more videos. Thank you.